Determine the following indefinite integrals. Bring your answer to each part in the box provided. You do not have to simplify your answers or explain your steps. So the first problem is a polynomial, so we can actually anti-differentiate this by undoing the power rule. So we add 1 to the exponent and then divide by the new exponent. 7x becomes 7x squared divided by 2 plus 12x, and because this is an indefinite integral, don't forget the plus c. It's a very big point deduction if you don't put the plus c. The next integral is the sum of two known derivatives. So this is the derivative of arc sine of x. So we can say this is arc sine of x, and this is the derivative of secant x. So plus secant x plus c. However, this is also the derivative of negative arc cosine. So either of these would be acceptable. You do not have to provide both, but some people, when they see this, arc sine jumps out of them. Some people would remember the derivative for arc cosine. And the rule with trig functions, both the arc trig and the regular trig functions, it is all of the trig functions that start with the letter c that have negative derivatives. So that's why the arc cosine derivative would have been that negative derivative, so it's okay no matter which one you saw here. This next problem is going to require u substitution. So you do have to provide a little bit of justification when you're doing a u substitution problem. So if I look at this, I see an e raised to something, which happens to be sine, and then I also have a cosine. So you want to be very careful when you select your u, because it is true that cosine and sine turn into versions of each other when we take their derivatives, but I want to make sure that I'm kind of honing in on the more complicated part of the problem to pick my u. I don't want to include e in my u, because if you try to take the derivative of an expression involving e, the e comes right back, and I don't have a second e to give up for my du. So I'm going to make u sine of 3x. Then I take the derivative of this and verify that I've selected the right u. So du is going to be 3 cosine 3x dx. So to verify that this is the right u, I look at my derivative and I go back to my integral and I look for all of these pieces to see if they're there. If they're not there, if it's anything but a constant missing, I've made the wrong choice and I need to try again. So I have a cosine 3x dx. So I have all of this. So if I solve this equation for what I have, I'm now ready to translate my integral into my new variable. So this is going to be the integral of e to the u. All of this is du over 3, and I'm just going to move the 1/3 out front to make it easier for me to integrate. So the antiderivative of this is 1/3 e to the u plus c, but I need to go back to my original variable x, so 1/3 e to the sine of 3x plus c. And that is what I'll put as my final answer.